Hi everyone, I'm Syarif Ikmal and today I will present to you about the introduction part. So what is wheelchair? Wheelchair is a mobility device designed to help people who have difficulty walking or unable to walk due to illness, injury or disability. Wheelchair can be divided into two types, which is manual wheelchair and electric or power wheelchair. Wheelchair also can be used both indoors and outdoors. So why we choose wheelchair for our mini project? We choose it because the standard wheelchair design does not meet the needs of user. So from that, we are trying to improve the wheelchair which can give much more benefit to the users. So what things that we give to user is the freedom to navigate their environment effectively, proper sitting and postural support, withstand daily use and various environment, ensuring long-term reliability and user safety. We also give them specific needs and ability of the user, including physical limitation, activity level, and preferred modes of propulsion, either manual or battery powered. We also make the wheelchair so that it can adapting to different situation and environment. And for our part of wheelchair, there is consists of front wheel, leg rest, hand rest, wheelchair frame, seat leaning, seat, back wheel, and side plate.
Hello everyone. Today I would like to present the justification for selecting a manual typical wheelchair as our proposed product. First of all, a manual wheelchair remains one of the most practical, reliable and affordable mobility solutions for individuals with physical disabilities. Unlike powered wheelchairs, manual wheelchairs do not require complex electronic systems or batteries. This makes them easier to maintain, repair, and operate, especially in areas where access to technical support or electricity might be limited. Secondly, the manual wheelchair is cost effective. It is significantly more affordable for users from lower income groups or for organizations that need to provide mobility assistance to many people, such as hospitals, rehabilitation centers, and care homes. Another important justification is simplicity and durability. The typical manual wheelchair is designed with durable materials like lightweight steel or aluminium, making it strong enough for daily use while still being easy to fold and transport. This is very convenient for users who need mobility both indoors and outdoors. Furthermore, the manual wheelchair encourages physical engagement for users who are able self-propelling the wheelchair, maintain helps maintain upper body strength and provide sense of independence, which is vital for mental health and personal dignity. In conclusion, the manual typical wheelchair is justified as the ideal product because it balances affordability, reliability, simplicity, and independence. It remains a timeless solution that continues the meet to meet the needs of people with mobility challenges worldwide. That's all for me. Thank you.
Now I will continue the reverse engineering. My name is Ahmad Okai bin Muhammad Shukri. My matrix number is 2024654326. For the first one, which is frame, we need to determine the outer diameter and inner diameter. So when we measure the wheelchair, we pull out one of the uh, wheelchair handle, and we can measure the inner and outer by using caliper. So we get the value or the inner diameter. So we use for endocardia, we use tool called rib to make a hollow frame, and we use material steels for this frame. Second one, we for the rear wheels. Rear wheels we can measure using measuring tape because it's so big. For the tire, which is made for rubber, the rims made for steel, but the push ring we use the aluminium. So we can measure by sometimes using caliper and sometimes using the measuring tape. For when on the katia, we use a tool called shaft to create a circular. We create a one one pieces, and then we should use shaft tools and one axis, and we can get the tire for the rubber. For the rims, we use a circular pattern. We make one rims that connect to the center, and then we circular pattern to get the another 6 to complete the product. The next one is the leg race. If you cannot see the leg race here, the leg rest here use the the bottom side is hollow, which is so we use the shell tools and edge fillet to get the curve fillet, to get a curved surface. The material for the leg race is aluminium. And the last one, we use front wheel. The front wheel, this front wheel, which is same like a real race, we use a shaft to make a circle rubber tire, and circular metal for the rims. You can see that they have both two materials, tire for the rubber, rims for the rim using steels, and also the part also on. Now we continue on the finance element analysis. For this analysis, we choose two parts, which is wheelchair frame and rear wheels. For the wheelchair frame, we apply the load at the where the seat connect to the frame. If the person sit on the wheelchair, the both right and left steel bar at the frame is apply force. So we choose that section part where they apply load. So we choose 600 Newton, which is average of 60 to 80 kilogram the weight of the person. So we can see here the maximum displacement of the section parts is 0.0926 millimeter. Therefore, the steel frame will not fail upon the load that has been assigned on the section part. Now we continue on the von Mises stress. We can see that the maximum allowable stress, which is 18.1 megapascal. From the general report from the CATIA, we get the yield strength, which is 250 megapascal. Therefore, we can calculate the factor of safety, which is yield strength divided by maximum allowable stress. So we can get the value which is 13.81. The factor of safety on the steel frame is the steel frame bar is over 1, which is design is acceptable. If the factor safety is less than 1, it means there are some permanent deformation which is not acceptable. Now we continue of the rear wheel part. We can see that we apply the load on the hub of the rear wheels, which is the center of the rims. This is because that part is connected to the wheelchair frame that when has apply load when people sitting on it. So we choose the center because there is a shaft connect to the frame. So we apply only 300 newtons. We divide the load by 2 because the wheelchair has two wheels, so each wheel apply by 300 newtons. So we can see here the maximum deformation is 0.000854 millimeter. Therefore, the rear wheel will not fail upon the load has been assigned on it. So we continue on the von Mises stress. We can see here the max allowable stress, which is 0.943 megapascal. So for the generate report, we get the value 250 megapascal. Therefore, we can calculate the factor of safety by information gathered. The so we divide the yield strength, which max allowable stress, and we get the value which is 265.11. The factor of the safety of the rear wheels is over 1, which is designed acceptable. If the factor of safety is less than 1, it means there are some permanent information which the design is not acceptable.
Hi, my name is Haris Izzat. Today I will be presenting to you about our discussion from mini project. Let me start. We are developing a new wheelchair designed to significantly enhance mobility, particularly for those in undeserved communities. Our project directly addresses the limitation of current designs, such as poor adaptability, high cost, and maintenance issue, which greatly impact user quality of life. Our solution focuses on materials, comfort, and safety. We are engineered a black powder coated steel frame for an optimal balance of strength, lightness, and rust resistance. User comfort is prioritized with swing away rest, removable armrests, and adjustable seating to prevent pressure sores. Safety features include strong handbrakes, anti-tilt bar, foam fill, and puncture-proof casters. Our manufacturing process utilizes precision engineering like CNC cutting, anti-IG welding for ensuring high quality and durability. Furthermore, we are validated the structural integrity with finite element analysis and prioritize sustainable practice by using recyclable materials and designing for repeatability. This new wheelchair offers substantial advantage in versatility, cost effectiveness, and user experience, effectively bringing the gap between engineering innovation and practical application.
Hi, my name is Aini Ridwan Bezafian. So I will talk more on our conclusion of our project and also the overview of all of our drawing and the part itself, the assembly. So in conclusion, we have successfully achieved our objective by designing a safe and durable wheelchair using the CATIA software as per the course requirement. We have also used the finite element analysis for in order for us to confirm its strength for the daily use. So the wheelchair itself actually include a key safety features such as the anti-slip mechanism and also the anti-slip or anti-tip mechanism, and also an ergonomic seating for the comfort of the user. The wheelchair itself are actually designed for an urban user, so in the city and some more with mobility issue, people with mobility issue, and also it is quite affordable for a wide range of people. So with the anti-slip wheels and a compact lightweight frame, it is simple for a user to use both indoor and also outdoor. So finally, this project has also improved our teamwork and our CAD skills. It helped us by applying our classroom knowledge that we have learned in our class, MEC 45, in order for us to solve the real world problems. So overall, I would say that our design actually met all the course requirement and have delivered a practical mobility solution. So moving on to the appendix, where I'll explain more on our each of our drawing part and also the assembly plus the bill of material. So as you can see, we have the front wheel and also the rear wheel that we have made. So each part of this are the assembly of our wheelchair. So the first picture, first drawing, which is the front wheel, we have designed it that way based off our research and also the intricate design of it. Based off our research, this is the best design for a front wheel of a wheelchair. And second is the rear wheel of the wheelchair, which is pretty much a wheel with a a handle guard for for the user to move the wheelchair. Moving on to the next part drawing, which is the seating part of the wheelchair, which we have seat leaning for the back support of the user of the wheelchair, and also the bottom seat where you actually sit in. The design are not intricate, pretty simple, straightforward. All of it are actually just for the sitting area, and also in our assembly it's actually pretty ergonomic, so quite comfortable for the user of the wheelchair. So next up is the main part of the wheelchair, which is the leg rest and also the frame. So we do most of our finite element analysis on this part, since most of the force will be distributed in the frame and also on the leg rest. So based off this drawing that we have, actually in the making of the frame, we actually have to make a lot of research on how to make the frame and how stable it is, and also the symmetrical part of the frame. And then we have the leg rest, which is actually simple enough, which we just use fillet for most of the part, for the smooth part of the leg rest. And finally, the last part of overviewing of our drawing, which is the handrest and also the side plate. This design is actually self-explanatory, simple. So basically, the side plate, we make the side plate after we make the frame, which we could just trace back the frame in order for us to make the side plate. And the handrest is actually just a handrest. So self-explanatory, and this part are actually pretty simple. And finally, moving on to our assembly drawing and also the bill of material for bill of material drawing. So the assembly drawing is basically just assemble all the part into one drawing, which is ours is the wheelchair. And also we have the drawing of our bill of material. So for each material or for each part, we have actually the quantity and also the name of it all. So that is it from us. Thank you for listening and thank you for watching. We hope to see you on the next designing course. So thank you very much.